This lesson is lesson 1-4, the properties of real numbers. You'll be identifying the properties of real numbers and also using them. Our guiding question, how do we use the properties of real numbers? Answer this question when you finish the lesson. The following video goes over the properties of real numbers. This is one of the homework video tutors from your book. I put the link in here, so if you have trouble understanding these properties when I go through them, you can go back through this video and see if it helps you. The properties from the video with definitions and examples are as follows. If we look, we first have the commutative property of addition. Commutative properties of addition and of multiplication deal with order. They deal with order. And what it means is when I add or when I multiply real numbers, I can list them in any order. As for example, 3 plus 7 equals 7 plus 3. And 3 times 7 equals 7 times 3. Our associative properties of addition and multiplication deal with grouping, which is parentheses, where I put them. If we look at our examples, our addition example shows I have the parentheses of 6 plus 4 here, and then the plus 5, and that would be the same thing as if I put the parentheses around the 4 plus 5 and have the 6 by itself. And the same thing with multiplication. 6 times 4 times 5 is the same thing as 6 times 4 times 5. Our identity properties are pretty much what the word identity means. Identity is like who you are. And in addition, if we think about what its identity is, 0 is the identity because if I add 0 to any number, I get that number back. So our identity property is like 9 plus the identity 0 gets us back to 9. The identity for multiplication is 1, since anytime I multiply a number by 1, I get it back. So if I have 6 and multiply it by the multiplicative identity 1, 6 times 1, I get the 6 back. Our inverse properties are the properties that tell us what we need to add or multiply together to get our additive identity and our multiplicative identity. So for the inverse property of addition, we know that for every A, there is an additive inverse opposite of A, so that when you add them together, you get 0. So for example, 5 and its additive identity negative 5 give us our additive identity of 0. The same as with the inverse property of multiplication. For every A, when A is not equal to 0, there is a multiplicative inverse 1 over A, also known as its reciprocal, that when multiplied together give us our multiplicative identity of 1. So for example, 5 times 1/5 equals the multiplicative identity of 1. And then we have our symmetric property. Our symmetric property says if A equals B and B equals A. Again, what's on one side of the equal side, if it's on the left and it equals what's on the right, I can switch their places and make what's on the right be on the left, what's on the left be on the right, and they will still stay the same. Now we're going to look at some examples from the book that involve using the properties of real numbers. If we look at example A, example A says 42 times 0. Since 0 is 42 times 0, that is our 0 property of multiplication. The 0 property of multiplication. It says 0 times anything equals 0. If I look at example B, I have y plus 2,5 plus 2,8 equals y plus the quantity 2.5 plus 2.8. I changed my grouping. So I have the associative property of addition. And in example C, I have 10x plus 0 equals 10x. 0 being my additive identity, and I get what I started with back at the end, so I have my identity property of addition. I would like for you to do the Got It problem 1, A and B. The following examples that we're going to look at deal with equivalent expressions. These are expressions that are equal. When you simplify, you are creating equivalent expressions. Each time you simplify, you come up with a simpler equivalent expression. If we look at example A, 5 times 3n. I know I can multiply the 5 and the 3 times each other because they are like terms. So using the associative property of multiplication, I can change those parentheses, then multiply the 5 times 3 and get the 15 for that final simplification step. For example B, I have 4 plus 7b in parentheses plus 8. If I look from here to here, what happens is I change the order. 4 plus 7b changes to 7b plus 4, commutative property of addition. Now going to the next step, instead of putting the parentheses around 7b plus 4, I put the parentheses around 4 plus 8, which is grouping, which is my associative property of addition. And then I'm able to add the 4 plus the 8, which is simply simplifying, or you could just say add. Example C, 6xy divided by y. I can rewrite the denominator using the identity property of multiplication, that 1 times y, which then lets me have this y divided by y here, and that equals 1. Anything divided by itself equals 1, and 6x times 1, which is our identity property of multiplication, gives us our 6x. So when they ask you to simplify each expression and give the reasons why, all you're doing is giving some kind of algebraic reason why you're able to do what you did. I would like for you to do problems 3, A, B, and C, simplifying and giving a reason for each step. And lastly, we're going to be talking about deductive reasoning. Deductive reasoning is the process of reasoning logically from given facts to a conclusion. So based on certain steps or facts along the way, I am able to reach a conclusion. To show that a statement is not true, you would need to find an example for which it is not true. An example that shows that a statement is false is what we call a counter example. And you only need one counter example to prove that a statement is false. So if we look at problem 4 here, it says, is the statement true or false? If false, give a counter example. Example A, for all real numbers A and B, A times B equals B plus A. I need to decide, is that true or false? And if it's false, give an example. So just start thinking of numbers. Put numbers in and see if you can find one that's false. So they found the example 5 times 3 and 3 plus 5. 5 times 3 is 15. 3 plus 5 is 8. They definitely don't equal each other, so that would be a counter example. Example B says for all real numbers A, B, and C, the quantity A plus B plus C equals B plus the quantity A plus C. We can get to that. We can simplify that statement using our commutative property of addition, changing the order, and then our associative property of addition. Here, the commutative property changed from A plus B to B plus A, and then I changed my parentheses for my associative property. So I would like for you now to do the got it problems for A, B, and C, stating if each statement is true or false. If it's false, give a counter example. If it's true, use the properties of real numbers to show that the expressions are equivalent, like they did in example B.